Yeah, the recording already started.
Okay, all right. Okay, thank you. So this webinar is being technically sponsored by two European projects, the CHARITY project and the ACCORDION project. It's really an honor for me to moderate this webinar, which is going to be about security in the future, basically discussing the challenges which are actually ahead of XR services and serverless computing. So we have two distinguished speakers here. So we have Pavel Sorokin from Cloud Sigma, and we have Edward Marin from Telefonica Research. As I mentioned, this webinar is being technically sponsored by the ACCORDION project, as well as by the CHARITY project. The overall objective of ACCORDION is to develop an orchestration system that enables next generation application developers to deploy their applications in a smooth manner on the available edge cloud resources. CHARITY aims for the same, but with more focus on targeting immersive services. So it basically it aims for building an autonomous orchestration system of cloud, edge, and network resources that support immersive services and meet their requirements in terms of latency, bandwidth, and so on and so forth. CHARITY aims to support 7 use cases, as shown on this slide. These include holographic concerts, holographic meeting, virtual reality, VR-based medical training, and so on and so forth. For both projects, cloud is a very, very important component, basically all cloud technologies. And security is a concept not to be compromised at all. So with this in mind, we have the two consortia have decided to organize this webinar, where we will be having talks about security in the context of cloud. So the first presentation, or the first talk, will be given by Pavel, and it's going to be on security for cloud-based XR services. Here I would like to briefly introduce Pavel. Pavel is a software engineer at Cloud Sigma. He studied computer science at Mittweida University of Applied Science. Before joining Cloud Sigma, he was working on end-to-end active roaming testing platform for mobile services and networks, and that include second, third, fourth, and fifth generation. In Cloud Sigma, his focus is on improving security posture by developing existing and new services and ensuring that security aspects help and do not slow down the software development lifecycle. And then we have the second distinguished speaker, who is Edward Marin. So he's going to give us a talk on serverless computing, basically seeing this serverless computing from security perspective. He's currently a research scientist at Telefonica Research, Spain. He holds a master's degree in telecommunication engineering from the Polytechnic University of Catalonia. So he obtained that in 2013, and he obtained his doctorate degree in engineering from the KU Leuven in 2018. Before joining Telefonica, he was a visiting research fellow at the University of Padova in Italy and a postdoc researcher at the University of Birmingham in the UK. Edward's research falls in the intersection of network and security. In particular, his work focuses on the security of new networking and computing paradigms such as SDN, NFV, programmable data planes, and serverless computing, which is going to be the focus of his talk. So with no further delay, I would like to invite Pavel to give his talk. But before that, I would like to remind you that this webinar is being recorded, and by attending, you're giving your consent to have it recorded. So thank you in advance for your attention. I would like to have this webinar to be interactive. So please, we'll let the speakers give his presentation. And towards the end, we would like to have questions from the audience. Thank you. Now I will stop sharing, and I will invite Pavel to present.
Okay, Tarek, you can see my presentation, right?
Yes, I can see it at my end.
Okay, cool. So, hello, I'm Pavel from Cloud Sigma, and we will talk today about the security for cloud-based XR services. And actually, it's not only about XI, it's just about the cloud applications. That's what we will talk about. And our agenda will be, we will talk a little bit about the risk profile for modern application in the cloud. We will take a look on the secure software developer lifecycle, take a look on the best practices and some kind of the takeaways, what we can do, what we can learn from the talk, what we can improve. And first of all, why does bringing security into cloud-based applications matter? Why it's important? Yeah. I would like to share this information first. This information comes from IBM report from last year. And actually it's interesting because it looks like the 52% of all cases of security data breaches across organizations happens from outside organization, but another 84% comes from accidents and mistakes with organization. It means the half of the cases could be prevented just by being more carefully and more accurate security approaches that actually could be taken. Let's take a look on the application, so how the modern application looks like. So on the left, you can see some kind of the imagination of how applications looks like. It's like an iceberg, right? And if you take a look on your source code and actually your application code, what you are writing, right? Usually it's about the 10 or 20% of the whole code that you have. This is your application code, so it means the source code you write in your IDEs, editors, and so on. And if you have any vulnerabilities there, it's code vulnerabilities, right? So you have some kind of you forget the escape the parameters or write some kind of it's possible to make SQL injection in your code and so on. So the another second part would be the libraries that you're using. And actually, it's roughly about the 80-90% of the code base that your application is using. You can imagine like login libraries, yeah, or you use some kind of the connectors to databases and so on. These open source libraries have vulnerabilities as well, right? So it means if you use outdated library or vulnerable libraries, your application is vulnerable as well. So it's not important to only take a look on your application code, it's the libraries you're using as well. And there's different concepts and some kind of the different concepts in the libraries. If you have vulnerability in your library, right, this library can have the library as well. It means that it's called transitive dependencies. And sometimes the vulnerabilities are in the transitive dependencies. It's actually about the 80% of this. It means you have to monitor, to track it, and to know how vulnerable you are. When we move to the containers, and we run in the containers, usually it's a Kubernetes or Nomad or another stuff. And usually it's a Linux container, what we're using, or what you are using. And you use the public images, public Docker images, for example, right? And these images has some tools installed like apt-image, curl versions, and so on. And this application can be vulnerable as well. So it means there's another layer on top of the libraries where your application is located in the image is the containers that you have to track and monitor as well. And the last but not least, this is the infrastructure as code. It means if you deploy your application on AWS or Google Cloud, you have to configure network access, storage, servers, and so on. And you can make mistakes as well, right? And actually, according to NSA report, the cloud vulnerability number one is the misconfiguration. So people forget to log the access, the port, SSH port is open or something like that, right? Let's take a look a little bit to the security software developer lifecycle. This is how it looks like, right? We code, build, test, release, deploy, operate, monitor, and repeat and repeat and repeat this. Yeah, so it means we have the developer side on the left and operation side on the right. And how we could prevent the vulnerabilities, or how we can improve the life cycle. It's actually to build the security gates, right? So between the stages. So if we code in the editor, we could introduce something that help us to find vulnerabilities earlier. In the CI/CD pipeline, we can do something like we can catch the bugs and catch security vulnerabilities earlier, make some kind of the gates. And during deployment, when we are running into, let's call it Kubernetes cluster, right, we can monitor images as well and scan the images on the fly. Let's talk a little bit about the SAST. Yeah, so it means our code, right, where we code something. And this is the static application security testing. It's actually, we focus here on the code, right? It means that's what we write. It's very early in the development phase. And because it's very early, it's very easy to test. Yeah, so you don't have any execution environment, so you don't need to spin up something. So it means it's only your source code. It's usually the parsing of the source code, finding hard-coded keys from AWS secrets, for example, or something like that, or another pattern. And it's easy to test, easy to find, and easy to prevent, sometimes with auto fixes, right? So if you would take a look on the software component analysis, this is exactly what we talk about, the libraries we are using, right? This is vulnerabilities in the open source dependencies. It's not so easy, but it's easier to scan as well, right? Sometimes we have the license compliance risk. So if your application is closed source, right, you may not use some open source libraries with some licenses. Right? You have to be aware what kind of the library are you using. That's important as well. And sometimes open source packages will be deprecated or unmaintained. So you would like to take a look and be sure that you are always on the use the latest one and not the 10 years old logging library, something like that. Okay. About the container security here. So if we talk that it's usually what you have in the container world. If you build the Docker image, you have the base image where you work on it, and when you add your application on top of it. So it's recommended to scan the base image, what kind of the vulnerabilities are available there. And sometimes there is different flavors of the base images, right? So if we take a look on the, let's call it Node.js, for example, image, right? There is a based on Debian, based on Alpine, and on the Alpine Node.js image, it's less vulnerabilities than if in comparison to the Debian, for example, right? Because of the amount of Linux packages inside of this image. Okay, and talking about the infrastructure as code, here is the most important would be the that we principle of less privilege. So we don't allow everything or what we would like. So we restrict SSH access, or so we allow only what we need if we configure our infrastructure. We do the network segmentation and use TLS and mutual TLS if we talk between the software components or between the your microservices. And we encrypt the data that actually go out and go in. Yeah, so if our microservices talking to each other. If we would like to summarize the best practices, what is important, how it helps to bring security closer to the developers. Yeah, first of all, we should educate our developers, right? So to show that security is important now, right? So basically it was important always, but now it's more and more important. Like if you remember, DevOps was earlier not the common practice, but now there is another approach that calls DevSecOps, right? So those developers care about security and take a look on the application earlier as well. Maintain the growth mindset. Yeah, so just to be always curious how we can make it better and so on. And implement other initiatives like I said, DevOps, security DevOps, and so on. It's helpful to start with a bigger problem first. Yeah, it means that security, it's not that you just try to solve every issue or every aspect of your application what you have. From my perspective, from my experience, I would say it's easier to start with software component analysis to track your dependencies, to analyze your dependencies. It's easier, and then expand the surface to the application code, to the SAST, then to the container scans, and to the infrastructure as code. So takeaways. Try to integrate security early as possible, right? And maybe most important takeaway from the whole talk that we're talking about, security is about the remediation, the fixes, right? So it means that we want to fix vulnerabilities. We don't want to report them and make have some nice reports and say, okay, now we know what kind of the security issues we have. No, it's about the fix and how fast we can fix them, yeah, and automate this process. And just iterate and check your security posture regularly. Security is a muscle that actually, like, you have to train it, and as soon you start it and you make it regularly, it's easier, right? I have the small demo from the project. So let's switch me to my IDE. Actually. There is a small project, and I want to show you how the different tools can show the same surface issue. So this is a Gradle application, Java application, actually. And most important here. So we declare dependencies, and one of them is Log4j dependencies. Yeah, for the logging. And you can see now, if I run the scans here, then you will see that there are 4 vulnerabilities, right? So from CVE, it's exactly for this Log4j core library. It's actually very high or critical dependencies. This is maybe you heard about this Log4Shell issue that was about 2 years ago, right? So that actually allowed to execute remote code just using the GNDI features, right? And for example, in IntelliJ, that would be the one approach of how to use SAST scanning here. You can see IntelliJ provides the checkmarks support. This is one of the security companies that allows to test your application. And you follow them. And if we switch to the terminal, so I switch now to the terminal, and I use another tool, it's called Snyk, that allows to test application as well. And you will see the same results. So we analyze dependencies, what we have. It means direct dependencies and transitive dependencies to find the whole, to build the whole tree. And then the database will be queried, and these 4 dependencies will be, security issues will be found, right? And one of them is really critical, so they have to fix it. That's what's the warning. You see that the different tools, but they found the same issues, right? And so start using one of them. It's not actually technically important what kind of the tool are you using. You just start with it, get familiar, and then just be more secure. Okay, this would be the demo. So it means how you can test it. And what I would say, develop fast, stay secure, and if you have any questions, please ask or write in the chat, so we can read it and answer it. Okay, this would be all from my side. So I stop sharing my screen.
Okay, thank you so much, Pavel, for this very interesting talk. Here I would like to invite the audience to ask questions to Pavel. Whoever wants to ask questions, please raise your hand, and then Yeah, I see no questions. Maybe everything was very clear. Just why? Oh, Louis. Okay, please, Louis, go ahead.
Yeah, just a quick question. What kind of open source tools do you think we should focus on this?
I see. From my experience, I would say there's different tools for different ways. Let's go from the open source. If you take a look at the open source, Sonalint is a very good tool. So you can use it for SAST scanning. So if you develop across IDEs, and they provide the vulnerability scanning for dependency as well. So I would recommend it because I use it, very good. And other stuff, I would say start with a Sonalint, a SonarCube, and then just improve and take a look on another one, right? And many tools, if you have the open source project, right? Many security companies allow you to have amount of scans for free, right? So just if you have it, so it just actually more important. They are all more or less the same, right? You just to pick one that actually more familiar, easier to configure. Sometimes it's important the ecosystem what you're using. For example, if you use, let's call it .NET, right, and use NuGet packages, right? Not every product supports a NuGet package. You just find what kind of the stack you have, right, and then take a look on the tools whether your stack is supported or not, right?
Okay, thank you. Louis, I still see your hand up. Is it all the hand, or you want to ask further questions?
Actually, I have another question for Pavel.
Yeah, please.
What do you think would be the role of AI in this kind of tools? We now have ChatGPT that can do a lot of things. What would be the role of this AI for these specific things in your opinion? Are you aware of already any tool using ChatGPT capabilities for scanning code and detecting bugs in a more intelligent way, let's say?
I would say a bit from the different perspective. I know that the company use AI to find vulnerabilities, right? And there's a lot of techniques what they're using, like scans the open source repository or repositories, or forums, or like Google groups where the developer discuss, find vulnerabilities, and they use AI just to filter information to find out, or to find out maybe the issues, check commits, yeah, to find what actually the commit messages. So this one of the areas that actually can be, I think, really be, I can imagine that can be used. From our user perspective, that use tools, we will see, I think, because of the ChatGPT, or we talk about the AI in the common, not about the only ChatGPT. It's still in my opinion, in discovering phase. So we just see what we can do with it, right? And for sure, we can help us. So if you talk about the IDE, just help us to ask correctly, or to help us to find this, right? So, or bring us to some ideas, or move us into the right direction, right? So this would be, but we'll see. The interesting time that actually will come with this whole tooling.
Any further questions? I mean, I have one question for you, Pavel. There is this concept of shift left security. So could you please shed light on it further, and why we need it even?
Yep, sure. This is a trend actually that, or the concept that will be actively promoted. And so if we take a look on the software development lifecycle, so we have left the development that we start coding, and we have right where we deploy, and the application is already somewhere in the cloud or on the premise platform. And shifting security left, it means we bring security closer to developers, and it will be easier to, or let's call it differently, it will be faster and cheaper to fix security vulnerabilities when you develop something, when you're in development, and it will be more expensive to fix it if you already have application deployed somewhere. And this shift left means we move this to the developer to make it more effective, in terms of how fast we can remediate vulnerability if it will be found, right? So because, for example, if security vulnerability will be disclosed somewhere and will be found, for you, like developer, it's most important how fast can you fix it, right? And if we bring it more closer to developer can fix it. This will have the positive impact on the application. So it's exactly, I would say, exactly like the DevOps, right? So how this developer and operation approach was, if we take a look at 10 years ago, how it was introduced. Say, okay, developer is not only responsible for writing the code and do nothing. No, they should help development and on operation side. And that's exactly how security and developer can work together to make more secure software.
Well, I mean, so far it has been build it and then secure it, and it seems it's not the right approach anyway. So thank you, Pavel. I think we can move on now to the next talk, which is going to be given by Edward. I have already introduced Edward, so his talk will be on serverless computing and basically the security aspects of it. So, Edward, the floor is yours.
Okay, so can you hear me well?
It will be great if you can get closer to the microphone, or you get the microphone closer to you.
Okay, I'll try. Is it better now?
Better, okay.
Yep, okay. Okay, so I'm going to start. So today I'm going to talk about serverless computing, and in particular about the security of it, an aspect that is often ignored when you hear about serverless computing. So this is work I've done with Diego Perin and Roberto Di Pietro. We have a magazine paper on this. So today I will try to give you a flavor of what we did. But if you want to know more details, I invite you to check the paper. Okay, so okay. Let's very quickly go through, okay, how did we deploy applications in the cloud when we first start with all this cloud explosion, no? So more than a decade ago, when we started moving applications to the cloud, what we used to do was we used to run our applications inside a virtual machine, right? In a monolithic way, right? Then at some point, we realized that this was not the best way of doing it. Sorry, I had having some issues to change slides. And then we went to the microservices type of architecture, no? Where we break an application into multiple microservices, and we run each of these microservices in a separate execution environment, like a container. Later on, more recently, we've moved to serverless. And why did we move to serverless? What were the disadvantages of these two different ways of deploying applications? Well, there are many disadvantages. Two of the most important ones is that in both cases, users had to configure the execution environments, both the VMs and the containers beforehand, with everything that was needed to run their applications. Okay, this is one of the disadvantages. Another very important disadvantage is that is the billing model. No, the billing model was very static. So what used to happen is that perhaps you have an application that you only use, or that your customers only invoke a few times a day, but you need to pay all the time. You always need to have a VM running with your application inside, regardless of how many times it is invoked and for how long it's used. Okay. So these are two of the main advantages, or sorry, two of the main disadvantages that bring us to what serverless is. No, and something that I want you to note here is that as we evolve and we try to overcome these weaknesses of these initial attempts that we had of developing applications in the cloud, things also become more complex. No? So this is a bit how an application looks when you use the ideas behind serverless. Okay, so as you see, there is more complexity, which it's complexity, and of course there's also a positive side. So in today's talk, I will focus on the security aspect, but I will first give a brief introduction to serverless to make sure that everyone is on the same page. Okay, so serverless is, as most of you know already, a new computing paradigm that is expected to be the most dominant way of deploying applications in the cloud. One thing I always like to say at the beginning is that the servers did not disappear. Okay, so it's called serverless, but still there are servers. It's called serverless because you don't need to care about the servers. You're not thinking. I mean, when I say you, I mean the software developer. Software developers don't need to manage and provision the servers. Okay, so what are the main advantages? Why do we want to use serverless? Okay, so with serverless, all the infrastructure management and operational tasks are moved from the software developers to the cloud providers. Okay, so by doing this, now we can achieve one very nice thing, and it's that software developers focus on what they do best, which is writing the logic of their application. This is one advantage. The other one is that it offers a pay-per-use billing model. So you only pay for the resources that you actually consume, and not the resources that were allocated to you. Another interesting aspect of serverless is that it allows you to have a more aggressive auto-scaling. Okay, so you can scale up much easily than before, and also in a more cost-effective way. So it's cheaper to scale up. But at the same time, one very interesting property that serverless provides is that you can scale down completely. So if you don't need your serverless application, if no one is using this, you can scale to zero. You only need to instantiate copies of your application when there is someone who wants to use this. This is not an academic experiment, I would say. No, so this is now a new computing paradigm for which there's a lot of research being done in academia, but it's also something that is being used in industry. The main cloud providers already offer serverless computing to customers. There are also some open source serverless platforms. And one important aspect of serverless as well is that at the moment, there are two main flavors of serverless: backend as a service and function as a service. Because of the lack of time, I will focus on the one that is more prominent today, which is function as a service. Okay, so in function as a service, the main idea is to basically divide the application logic into a set of small, short-lived, and stateless functions. Okay, I would like to highlight the stateless characteristic of the functions. By doing it stateless, what we want to achieve is we want to decouple the compute and the storage so that these two aspects can be provisioned, managed, and priced differently. Okay. So let's move forward. Just to give you an idea, this is a very simplified image. Okay, I mean, again, I want to focus on the security, but I still want to give you a flavor of how this would look like. Very briefly, what we would have is a set of worker nodes, servers, that basically run our functions. No? So these functions run inside containers, and this is one option. These functions could also run in other types of execution environments. But the point is that you can have multiple of these functions running at the same time. At the moment, all the realizations of function as a service are event-driven. Okay, so there is a lot of emphasis on defining events that basically trigger your functions to be initiated. As an example, you could have an application that basically says, okay, if I receive an email, okay, that means that something is happening, and when this email is received, I will create that function to handle that email. Okay, but if no email is received, no function is created. Okay, so this is one type of event. Another type of event would be, for example, maybe I'll give you one example that probably most of you know. When you, for example, want to book a flight and you go to the website of the airline, there's a chat, no? And this chat typically is implemented in serverless. No? So when you start the chat, there's a function or a set of functions that are being created at that moment and that will handle your request. Okay, so of course functions are stateless, so we need cloud services to keep our data, different types of data. So this is something that is provided by the cloud providers. So cloud providers offer specific services. Each of them provides slightly different services with slightly different names. No, we've heard about S3 and other similar services for storing the data. And basically, from here, what I want you to keep is this: that it's event driven. So functions are triggered by either external events coming from the users, no, like for example sending an email, or you initiate the chat, or you post a tweet in Twitter, or you send, you post something in Facebook. There are really lots of events, and the idea is to provide, let's say, APIs or services for users to integrate with these events. Okay, I will move to the security. No, okay. So security-wise, I mean, why is this important? I mean, at first sight, one could think that security of serverless is, I would say, better than with the previous models. No, I mean, functions are short-lived, they are stateless. This makes attacks harder, right? It makes it harder for adversaries to remain in the server and sorry. I'm sorry, I lost the connection for a bit. Okay, so it's harder for the adversaries to perform attacks if the functions last for a very short period of time. Okay, so let's try to think about the threat model. So threat model wise, why do adversaries want to perform attacks in serverless? Okay, so adversaries want to perform attacks, of course, to steal sensitive information, cryptographic keys, the logic of the app. Perhaps they want to exfiltrate data. No? So they want to find a way to move data from inside the cloud to outside. They may want to change the control flow of the functions. So if the functions are supposed to be executed in one way, adversaries may want to change this in a different way for their advantage. They may also want to disrupt the applications. We can think of denial of service attacks, for example. Another type of attack that adversaries can do is, for example, they may want to run their applications without being charged. No? So now we have a pure pay-per-use billing model, where basically I pay for what I use. So now, could I trick the cloud provider into thinking that what I'm using is something that is being used by someone else, so that this someone else pays the cost of my executions? Okay, so this is what it's called a denial of wallet attack. Who can do this? These attacks can be performed by external and internal adversaries. Okay, so external adversaries mostly can leverage the APIs that you use to handle the events. That's the main entry point, I would say. I mean, the entry point is huge, because there are really lots of events being supported, and of course each of them has its own format, its own way of encoding information. So the more events you support, the larger the attack surface becomes. But of course, it's also very easy to deploy functions now in the cloud, right? So we could think of an adversary who can also deploy a function with malicious intentions, and that malicious function may want to escape the container or the execution environment what it's running, and may want to escape the container to compromise the host or to compromise other functions running in the same server. In addition to this, we and also this is a widely known concept in academia, we like to think about the cloud provider as an honest but curious entity. Okay, so there's a lot of work, especially in academia, where we're trying to protect against cloud providers who may want to infer information about users while behaving correctly, while doing their job and serving the applications of their users. So serverless computing has some pros and cons when it comes to security. As we were saying, functions are short-lived, so now it's no longer possible to have long-lasting attacks. No, that you compromise the server once, and you stay there in the server, and you can perform attacks without being noticed. So this is no longer possible, right? So typically, when you do attacks, there's a reconnaissance phase where you're basically collecting information. You're trying to see what's the best way of penetrating, and this reconnaissance phase in serverless, the adversary needs to repeat this very frequently, right? Because the function lasts for a very short period of time. After this, the attacker will need to repeat and repeat and repeat the same process, and it makes things harder. Certainly, it doesn't make attacks impossible to perform, but it certainly raises the bar for adversaries to perform attacks. Another positive thing is that security is now a shared responsibility. So when you think about serverless security, you typically talk about security of the cloud and security in the cloud. So security of the cloud is now the responsibility of the cloud provider. And this really includes lots of things. I mean, including patching the OSs of the machines where your applications are running, your functions are running, right? So this is a task that before used to be done by the software developers, but now it is one of the responsibilities of the cloud provider. Okay, of course, that doesn't mean that software developers don't need to think about security. They still need to think about the security of their applications, which is what we call security in the cloud. And this is still an open issue, and it's not easy, right? But the fact that some of the responsibilities are outsourced to the cloud provider facilitates things, and you could think that it eliminates a number of attacks. Of course, serverless computing very naturally mitigates certain types of denial of service attacks. I mean, you can scale up. No? I mean, if you're receiving lots of requests, you can very easily scale up, unlike other paradigms of cloud computing. The problem here is that, of course, you can scale up, but of course, you're paying for it. No? So someone may want to launch another type of DOS attack where the goal is not to disrupt your application, but the goal is to increase the cost that you need to pay at the end of the month or at the end of the year. Okay. Still, I put this as a positive thing because I think that preventing against traditional DOS attacks is very positive. At the same time, there is also a much larger attack surface. Okay, so and this is mostly because of the events. Okay, so now, I mean, for example, I have a slide for each of the negatives. I wanted to go briefly through the. Let me see. Sorry. Okay. Yeah. So, for example, in AWS Lambda, which is the serverless of AWS, at the moment there are 47 internal and external events supported with multiple formats and encodings. And of course, these are, you can think of these as entry points to the functions. Okay? Of course, the more entry points, the worse when it comes to security, because of course there will be some vulnerabilities that the security experts that have designed these APIs won't have seen, and that adversaries will be able to exploit. In fact, there are already lots of examples that show how to break into serverless functions. And of course, you need to think that the trend is to offer more and more services to be able to support more and more applications, right? So cloud providers really want to extend what they can offer in that sense. Another thing is, as you may have seen in one of the first slides, that of course, as you break a complicated application into smaller pieces, there's a lot of function-to-function communication and a lot of function-to-cloud service communication. Okay, which basically means that, sure, you can try to define and enforce more fine-grained security mechanisms, so more fine-grained security policies, but doing it well is very hard. The serverless ecosystem is very complex and very dynamic. There are lots of functions that run for a few milliseconds, and they run in one server now, they may run in another server later. Of course, each of these functions may need to access a very specific piece of data stored in a database. As you can probably imagine, it's very hard to do these things well. potentially there's the potential of, if you have the right people and they really know how to do it, I would say that you can achieve better security because you can secure smaller pieces, but doing it well is trickier than before. And of course, the trend with cloud computing, I mean, we've seen it from the early days of cloud computing, and I think it's even more prevalent now. It's that you want to lower prices, and you want to lower prices by sharing more and more, right? So you want to run, I mean, before you would have a few VMs in every host, but now the fact that you have functions and that they run in containers or even lighter execution environments, what it means is that you can put more users in the same server. You're also sharing cloud services, right? All this is shared. And of course, there are lots of optimizations that cloud providers are making to make it better for the performance of the applications, better because it's cheaper. And of course, the price to be paid is a lower level of security. Okay. The next one is this very interesting trade-off about security, performance, and cost. No, so it's a bit what I was saying. There are different choices that, of course, have an impact on the performance that the applications of the users can achieve, on the costs, and also on the security. Okay. I mean, without going into the detail, because I have quite a few slides. The main point here is that security is often that dimension that is the one that is being considered the least, I would say. No, so the main I would say requirement would be to achieve the performance that the software developers want, right? And for example, to achieve such performance, perhaps you need to reuse containers. No, instead of running a function inside a container for a few milliseconds, handling one request, and after handling this request, destroying the container, you may want to use so-called warm containers. You, instead of creating, like booting everything and creating the container from scratch upon receiving a request, you may want to reuse a container that has already been bootstrapped to handle a request for a given function. Okay, and of course that comes with implications. So that there are quite a few attacks that leverage this kind of choice. There are also some attacks that, well, basically you can try to leverage the fact that you can predict where the serverless functions will run. Okay, and of course I don't know if you're aware of this, but there are many attacks that have been proposed that can only be performed if the victim is collocated with the adversary. So it's really an advantage to be able to influence the way serverless functions are placed in the servers. Okay. There's another point that is also very interesting here, and it's that the cloud provider backends. Okay, now, of course, as I said before, cloud providers are largely responsible for providing security. Okay. The problem with this is that this may give a false sense of security to software developers. Okay. Software developers may think that security is no longer their responsibility at all. Okay. Or they can make unrealistic assumptions, or there might be some misconceptions on what is who is responsible for what. In addition to this, I also think that another problem is transparency, and it's that at the moment, when you deploy serverless functions in the main cloud providers, you don't really know which kind of mechanisms they are using to protect your functions. Okay, so the information about the backends of the cloud providers is often kept confidential, or I mean, at least it's not fully documented to the point that security experts can scrutinize this. And we've seen many examples where we've seen this kind of security through obscurity type of design, which is typically the fact that you don't document something is typically to because you think that by not doing so, you will make it harder for adversaries to get in. And what we've seen, especially in academia, is that this is not true. I mean, eventually, attackers will find the way to understand exactly what you're doing. And of course, I mean, here the main point to keep in mind is that there should be more transparency. And the fact that this is the responsibility of the cloud providers doesn't mean that we should not know what are the exact security mechanisms that they're using. Okay. Okay. So there has been quite a lot of work on trying to reverse engineer these backends. No, so some researchers have asked questions like, how are functions instances placed? How are the resources assigned and managed? How is isolation achieved? No, so I think that this is a very interesting line of work. No, like what these researchers have been doing is they've been placing different functions there. They've been making requests in a certain way, and they've been trying to figure out the way the cloud provider does things. Okay, so now we went through the positive and negative aspects of serverless computing when it comes to security. Now let's go briefly to the attacks. Attacks, there are, I would say, 3 types of attacks. There are application level attacks. So these are attacks like that we all know that can be launched against, they are application layer type of attacks, which I'm not going to cover because they are extremely similar to the attacks that we all know against the web. There are also some serverless specific attacks, and this is what I'm going to concentrate today. And of course, there are some hardware attacks. I mean, this is not specific to serverless. This is more cloud, like cloud-related attacks. No, that's okay. You exploit some micro-architectural weaknesses, some memory, like the row hammer type of attacks. The important thing to keep in mind here is that these hardware attacks are habilitated, or you can perform them only if you're collocated in the same place where your victim is. Okay, so you may want to use one attack in 1 or 2 to make sure that you're collocated with the victim, and then you can go to a more sophisticated attack that is more, let's say, hardware oriented. Okay, I'm going to skip this because of the lack of time. Okay, but this is very standard. Of course, I would say the best practices here is that you treat every function as a security perimeter. You don't make any assumptions on what the functions that come before one function are doing. So you need to parse things in a safe way. You can always get malicious input, right? So you cannot make any assumptions about your surroundings. Of course, you need to keep in mind that you still need to write code using the standard best practices. No, you also need to follow the privilege of least. The principle of least privilege. Okay, this is extremely important. And I mean, this is a very basic thing, but I always like to say that you always need to secure data at rest and in transit. This is, and of course, possibly as well in execution. No, but this is the securing it at rest and in transit is really, really fundamental. Okay, so I want to go. I mean, I don't know how much time I have. I just have 2 or 3 slides more. I'll finish in 3-4 minutes. I want to briefly touch on serverless specific attacks. So things that we may not have seen before that serverless may allow an adversary to do. The obvious one is this resource exhaustion type of attacks. No, like for example, denial of wallet attacks. Adversaries could find ways to trigger your functions many times so that your cost increase. Okay, there are different ways of doing this. I'm not going to go into the details in today's talk, but you may think that these kind of attacks are, let's say, relatively easy to defend against. No, you could set some thresholds, or you could say, okay, if you receive this many requests, just block everything before it reaches your function. But there is no perfect solution, and every single defense that you can think of leads to other types of DOS attacks. Okay, so this is quite challenging. There could also be some attacks. I mean, now that we have such a, I would say, distributed type of platform now, where we have maybe multiple instances of the same functions, maybe the data of the functions is not only in one cloud service, but maybe in a few of them, a few instances of them. So suppose that you want to change the permissions. You want to change some parameters associated to the functions. You want to change the, the policies. No, there might be a time window where some of the functions will run with the most up-to-date policy, and some of the functions may still run with the old one. Okay, of course, that also opens the door for race conditions. So there's a lot of stuff to be investigated here. And I think that the most interesting one to me is side channels. I mean, now the more you share, the more side channels there will be. Okay, I mean, at the moment, serverless security remains very unexplored. I mean, there are a few works, but no one has yet looked into the real security problems of serverless. But I think that this is one very interesting direction. And in fact, we're looking into this. Okay. Okay. Let's see. Okay, and I think with this, I think I'm on time more or less. I would like to conclude by saying that we have this paper sketching a bit. I mean, looking at the security of the serverless computing paradigm. So this is a magazine type of paper. So we saw that no one had done this before, and we thought, okay, before really getting our hands dirty with some very strong technical work, let's first try to identify what the attack surface is, what are the positive and negative aspects of serverless computing, and let's try to think about possible directions to try to encourage researchers to do research in this topic. And I mean, last but not least, and I think that this is also very important. No, I see lots of papers now on serverless, but I don't see much interest on security. No? And I think that security and privacy will be one of the key factors that will affect to which extent serverless in the end becomes one of the main ways of deploying applications in the cloud. So with this, I would like to thank you all, and I will be happy to take any questions you may have.
Thank you, Edward. Indeed, we're slightly over time, but probably we can manage to get a little bit, some questions from the audience. Again, whoever wants to ask a question, please raise your hand. Mike, please go ahead.
Hi, thanks very much, Edward, for that. That was really interesting. I'm just curious about what is like serverless. It seems like it could be quite a leap to jump to a serverless model if you had an existing architecture, just the same way that people have problems going from monolith to microservice. Mm-hmm. So going to serverless, like even as a development environment, you have to have some kind of serverless support locally that you have to stand up. There's integration testing, debugging it, tracing it. So I guess it is, if you were to start with serverless and build up your expertise, I could see it being quite powerful. But how much of a lift is it to move to a serverless model?
Yes, this is a very good question. There's quite a, there's a significant curve. I think it's very important to know what serverless is good at and what serverless is not good at. Okay, so serverless is very good at anything that you can run in parallel. So think about something that where you may want to parallelize things like ML related tasks. For example, serverless may not be the best option if you have a service that you want to run all the time. For this, you probably need a microservice or similar. No? And I think that this is very important. I think that before you make the effort, in terms of money, in terms of time, to go serverless, you need to think very well which kind of application you have. Why do you want to do it? You probably also need to make an estimate on the costs. No, so if you now have your application deployed with microservices, you're probably paying a certain amount of money. You need to see if serverless can be the good way to go, also money-wise. No? If it really depends on how much it's going to be used. But certainly, it's not easy. not only from the development point of view, but also from the security point of view. No, I would say that serverless security requires a change in mindset, and you need to think about security in a different way. I mean, the tools that you used to use before, you can no longer use them. Now, some of the responsibilities that you had are shifted to the cloud providers, but you're still responsible of the security to some extent. I think that there's a bit of a mindset shift that people need to go through, and you know, I think it's going to be very important, serverless for sure, but you need to think very well before to see if this is the best way of deploying your application.
Okay, could just one other thing. Like, I mean, I guess with the, as you were saying, the security that is going on behind the scenes with the cloud provider is it's a little opaque. So I guess that introduces risks if you want to move from one cloud provider to another, because you're moving from one unknown to another. And in general, with serverless, how much do you become captured by a cloud provider? Because you're relying on all this infrastructure that you can't see, and I guess they all provide different serverless functionality that you pick up, and then you can't move. You're stuck. Yeah,
it's the same problem as before. So each cloud provider has its own set of services. I mean, of course, the same set of services is what all these providers have. No, so if you want a database in AWS, you will call it one way. When you move to Google, they will call it in a different way. But there's still you need to choose also very well to which provider you go, because you will need to get familiarized with the set of tools that they make available to you. This is still a problem. I mean, I would say that this is probably the same as before. No, you choose one, you need to understand very well which kind of services and tools they offer. And of course, if you move to another, you need to repeat this effort, which is something that you would like to avoid.
Okay, thank you. Thank you.
Thank you, Edward. Any further questions from the audience? I see no hands being raised. I mean, from my side, you have mentioned this denial of wallet, or what's known as economical denial of service or denial of sustainability. It is actually a major attack issue that could happen easily in serverless computing, mainly when I mean, the auto-scaling system is not functioning in the right way, or it's very sensitive. So, I mean, did you capture that in your paper? Did you investigate what's happening in the literature about this?
So yeah, there are in the literature, there are a couple of papers on this. There's still, I mean, I would say that the state-of-the-art solution is still not great. It's still a paper published in one of the best security conferences, but I think that there's a lot of room to improve. And I mean, this is not. I mean, I always like to say this, no, that it's not an academic type of problem. No, so there are companies that have had this kind of problems. No, that they could not control well the cost. They didn't define any mechanisms to avoid having very large costs, and at the end of the month they got a significant bill, either because of what you're saying. No, it could be an attack, it could be a misconfiguration, right? Yeah. One is something that is triggered maliciously. The other is a human mistake. Both can happen, and both lead to the same kind of problem, no, which is you having a bill that you didn't expect.
Well, I mean, it's a very interesting research problem, and also when it's combined with liability, because as you said before, cloud providers are actually supposed to be secure, or they are supposed to be provided with security. But when they become the source of the problem themselves by charging you a lot, then yeah. Okay, I have many other questions about this, but I think for the sake of time, maybe we can close the session. Once again, I thank you, Edward, for this very interesting insights about security in the context of serverless computing. I thank also Pavel for his talk about how cloud-based applications should be built with security in mind, or security by design. I hope that these talks were also found interesting for the audience. The webinar has been recorded, and I think the organizers will put it available somewhere on YouTube or on social media. So once again, thank you all for attending, and maybe see you in another webinar sometime soon.
Okay, thank you very much.
All the best and goodbye.
Bye-bye.
Bye-bye.